All right, so here is a quick video on how to do stoichiometry. All right, so we have a reaction with a problem. So if I have 10.5 grams of carbon dioxide, and it's coming from a reaction where I'm degrading sodium bicarbonate, otherwise known as baking soda. Here's the reaction. I have 2 moles of baking soda will give me 1 mole of CO2. So the question is if I have 10.5 grams of this, how many grams of this did that come from, did I start with? So I can do this in 3 steps. Start with what's given. 10.5 grams of CO2. Always write the labels. Labels never lie. If you write the labels, you'll put everything in the right place. You'll always do the right math. Now I have to convert that to moles. I have a molar relationship. 1 mole of CO2 weighs 44 grams of CO2. It weighs 44 grams. That comes from the periodic chart. So if I do that math, put it in my calculator, I did it ahead of time, I get 0.239 moles of CO2. So this quantity is that amount. This mass is that amount. That gets me CO2, but I haven't answered the question yet. I have to relate these two to each other now. So that 0.239 moles of CO2, I need to find out how many moles of baking soda that corresponds to. So what I want goes on top. What I'm leaving behind goes on the bottom. And remember I said it's 1 mole of this from 2 moles of that. So the amount of CO2 I actually started with will produce 0.477 moles of NaHCO3. Okay, but I haven't answered the question yet because I still need to get grams. So I have 1 more step to do. So because I have moles here, I want mole on the bottom to cancel as a label. And the molar mass of this is 84 grams. And again, add them all up from the periodic chart, multiply, and it turns out that in order to make 10.5 grams of carbon dioxide from this reaction, I had to start with 40.1 grams of NaHCO3. So you can do this in 3 steps. The logic is I have to get moles of what I'm starting with first. Once I have moles, I can relate them in the equation because the equation is like a recipe. It tells me the proportions of each thing. So then I know how many moles of what I'm looking for corresponds to the amount I'm starting with. But in order to answer the question, if I'm asked for grams, I have to take that amount of moles and convert it back into grams of that substance. So first step is converting to moles. Second step is relating the substances in the equation. Third step is converting back into grams of the new thing, the thing you're trying to solve for. I could also write each of these steps out in one long stream. Some people like to do that. So I'm just going to slide over here. I could make the same thing look like this. So there's my CO2. First step is always convert to moles, so mole goes on top. And if I'm just thinking the logic, I can then go, all right, so I got moles here of CO2. I need to get moles of product, in this case the baking soda, the sodium bicarbonate. So again, that relationship from the equation. And then to get to grams, I need grams of NaHCO3. Notice how I'm kind of putting labels in first here. And in 1 mole, that weighs 84 grams. And it's the same three fractions. I'd do the same math. I would get the same answer. Right? It's just a different way of writing it. And how do I know I did it right? Because look, grams cancels out. Moles of CO2 cancels out. Moles of NaHCO3, oh, I didn't put it down here. Always do that. Cancels out. And I'm left with grams, which is what I want. Labels never lie. If you put the labels in, it'll tell you how to align your fractions, your relationships, so that each number is in the right place. So you're multiplying across the top, dividing by the bottom, and what you start with will always lead you to the right answer.